Okay, so this time we're going to do the inverse of a quadratic. So the first thing again that I would do is go to my graph and let's graph it. Now, you need to remember, we talked about it in class, that quadratics will have to have a restricted domain, is what we call that. Because if it's not restricted, then it is not a function when we do the inverse. So we're only going to graph where it's greater than or equal to 0. And so hopefully you remember that I'm going to take my parabola and move it down 2. Okay. And if you need a bunch of points or some point, whoops, I didn't need that one. I just said not to do that. On there, so I could put in a 2. And a 2 is going to give me 0. And if I put in a 3, if I put in a 3, that would be 9. That would be all the way up to 7. 1, 2, 3, 4, 5, 6, 7. Okay, so basically, whoops, here is my graph. Okay, so it's going to look something like that. Again, reminder to go in and put your y equals x line. So we know, again, we can look at the graph of the reflection. And then let's go ahead and find our inverse. So again, go through the steps. The first one is to put a y for the f of x. Next step is to switch the x and the y. And then the final is to solve for y. So I'm going to add 2. So x plus 2 equals y squared. Now we square root both sides. So the square root, whoops, that looks bad. The square root of x plus 2 equals y. Last step is to change the y back out for the f inverse of x button. Okay. Again, we're going to graph that. So remember that your square root is a parabola laying on its side. It now has a plus 2 here. And remember, if the plus 2 is inside, it is actually moving it the opposite. So it is minusing 2. If you look at the points that we have over here, I had the point 1, negative 1. So I have negative 1, 1. I had the point 2, 0. So I have 0, 2. And I had the point 3, 7. So that would be the point 7, 3. I don't know that I have enough to do that. 1, 2, 3, 4, 5. I didn't make mine over. So anyway, we can sketch it in. Okay, so forth, and have our curve. Okay. So does it look like it is the reflection over the y equals x? And one of the ways that you can look at that maybe is your perpendicular distance from here to here should be the same as from here to here. So when I come in here, maybe, because this looks kind of odd, if I do from purple to that perpendicular distance or from green to that, I should get the same distance. And I do in this case because they cross. Okay? Mine looks kind of funky, but you could actually do yours to scale. Okay? But anyway, that's how it would be. Again, try to get it. I would say if you're uncomfortable with your graph, plug in more points. Okay? That would be my suggestion on there. Okay. We're going to check it with our f inverse. Okay? So again, now we just need to do f inverse, and f inverse, f. Again, f inverse into f. So we're going to go this one into this one up here. Again, if you need to highlight it, I like doing that. I'm taking my f inverse and I'm putting it into my x. So I'm going to have, I'm going to come down here because I didn't leave quite enough room. But the square root of x plus 2 squared minus 2, which those will cancel. So I've got x plus 2 minus 2 which is just x, so that one works. This one, I'm going to take the f into the f inverse. See if I can semi-erase that without making too much error. Okay, and so this time we are putting the f into the f inverse. So I'm going to have the square root of x plus, or x squared minus 2 plus 2. And when I simplify that, again, these are going to cancel. I've got the square root of x squared, which is x, which works. Okay? So that is doing a quadratic to a square root. Okay? I was going to do a square root to a quadratic, but I think if you can handle this, you should be golden. Again, going back to my comment earlier, that if ever you don't feel comfortable with your graph, then do you a t-table and just plug you some points in. So in here, I could have gone in with 1, 2, 3, so forth, and got me some more points so that I felt more comfortable with my graph. Okay?